Hi, welcome to my video on solving exponential equations with the power of the base as an irrational number. And this is part 2. This video, or should I say in the previous video, we looked at where the powers were irrational numbers, but we found the answers to the nearest 100. In this video, we're going to find the answers as the exact value, which means you're not going to come up with a decimal as an irrational number. Let's do some examples to show you what I'm talking about. Find the exact values of x. Notice that 2 to the x equals 11. X is in the exponent, so we have to do the log of each side. So we get the log of 2x equals the log of 11. And because of the power rule, x moves in front, so it's x log 2 equals log 11. And we divide by log 2 to solve it for x. So we have x is equal to, they cancel out, the log of 11 divided by the log of 2. And that's the exact value. Or you could also have, that's the log of 11 when the base is 2. Because the log of 11 base 2 is the same as the log of 11 divided by the log of 2. And if you want, you could check and get I'll use my calculator here, but I'll just turn my calculator on and do the log of 11 divided by the log of 11 division log 2. And this is an approximation, 3.46. So that's to the nearest 100, 3.46, but this is the exact value. So if we took 3.46, so x is approximately 3.46. So if we took 2 and raised it to the 3.46 power, you get close to 11. But this is the exact value. The log of 11 divided by the log of 2, or the log of 11 base 2. Let's do another one. We've got to find the exact value. I had two e's here. It's value, V-A-L-U-E. Okay, just a little spelling error. And again, x is in the exponent, so we'll do the log of each side. Okay, done. And so the power x minus 1 moves in front times the log of 3. And it's easier to divide by log 3 first. They cancel. So I get x minus 1 equals the log of 40 divided by the log of 3. And so x equals the log of 40 divided by the log of 3 plus 1. So that's the exact value. And again, you could change this to a decimal, add 1, and put it in to see if you're close to 40. Another way to do that, instead of dividing here, we could from here, or should I say from right here, let's take off on this step. We had x minus 1 log 3 equals log 40. So I can multiply x times log 3 minus log 3 equals log 40. Okay, and I just want to explain here. Why did I put the x in front of the log? Well, when I multiply, I wrote down x log 3. I did not want to write down log 3 with an x, because you would think that's the log of 3x. So I put the x in front of the log 3, so to say this is x times log 3. It's much better than this, because I don't know if this is the log of 3x, which is this, or so that's why I put the x in front of the log. Now we have x log 3 equals log 40 plus log 3, and x log 3 is equal to, and the sum of two logs is the log of the product, and we divide by log 3 on each side. So x is equal to, they cancel, the log of 120 divided by the log of 3. Or we could also say that's the log of 120 base 3. So we got, this is the exact answer, or we could have this as an exact answer. Either or makes no difference. They're the exact answers. And again, 3 to the watt power gives you 120. Well, 3 to the fourth power is 81. So this number here is more than 3, probably 4. If you take the log of 120 divided by the log of 3, you get 4.36. Put that in and it'll get close to 40. So this answer works out to be approximately 4.36, and this one works out to be approximately 4.36. The two answers are the same. Again, I'm stressing the exact value. And now we have another different equation. Again, x is an exponent, but I have x on each side, so we still have to do the log of each side. Why? Because when you do the log of each side, the x comes down from the exponent in front because of the power rule. So we get x. And now I can divide by, I have that done, I can divide by log 15. They cancel, so I have an x minus 2 equals, if I do that, yes, I could do that and work this out as a decimal. Or okay, I'll continue on with that way. And that is x. So now I can take the log of 3 and change it to a decimal. So log 3 divided by log 15, log 3 division log 15, that gives me a decimal. So that's to the nearest hundred, that's decimal 41. So that's 0.41. So that's x minus 2 equals 0.41x. So x minus 0.41x equals 2. When we subtract here, we get 0.59x equals 2, and divide by 0.59. But this is not an exact value. So really, this would be wrong because I can't change this. I have to leave this alone. So what happens, rather than do this, let's go to this step. Let's go x minus 2, because to do this, I change it to an approximation. That would be totally wrong when I want the exact value. So let's do this, and let's multiply log 15 by x, so I get x log 15 minus 2 log 15 equals x log 3. Now, notice I got an x here with log 15. I got an x. So I'm going to group the x's together. So I'm going to bring this to the left side, x. It's the negative up. That's a plus. We're going to make it a minus. And move this is an irrational with a number, so it's a constant. So we'll move that to the right side and make it positive. Notice x is in both of these, so I'm going to factor out the x and get log 15 minus log 3. 2 log 15. So I'm going to divide by log 15 minus log 3 on each side. This cancels out, so I get x is equal to 2 log 15 divided by the log of 15 minus the log of 3. And we can make that a little bit better because we can simplify this. So that's this 2 in the front is a power, so that goes to there. The subtraction of 2 logs is the log of the quotient. So I have 15 squared is 225, and 5 divided by 3 is 5. So to bring it down, again, I can't do this because this is approximation. So to multiply by the log of 15 and move the x's to the left side and factor it out will give you this. So another name for this number This is the log of 225 base 5. So the log of 225 divided by the log of 5 is the same as the log of 225 base 5. And again, the x value comes out to be approximately, if you do your calculator on the log of 225 divided by log of 5, you'll get 3.37 approximately. So if you put 3.37 here, subtract 2, and that's 1.37. So 15 to the 1.37 and 3 to the 3.37 are approximately equal. So again, notice what I did. I wanted the exact values, and this is this skill here to group the x's together on the left side and factor the x out. That's a good skill to learn now, to get used to. You'll need that in calculus when you do derivatives and that little skill. Okay, let's do another one. This time we have a different equation, but notice we can simplify this equation here. This is the base is 3, and so we go 6x plus 6, and when we divide we subtract. So this is 4x plus 5. And this is 3 to the 6x plus 6. The subtraction makes it a negative 4x minus 5. So we have 3 to the 2x plus 1. What that does, it makes it a little bit easier when we do the log of each side. Notice the x is in the exponent of each, so we'll do the log of each side. The log of each side, and that means the power moves to the front, so 2x plus 1 log 3 equals x plus 2 log 6. And rather than divide here, and it's easier to multiply 2x by the log of 3, so there's 2x log 3 plus log 3. X times log 6 is x log 6. 2 times log 6 is 2 log 6. Now we have an x here and an x here, so we'll group the x's to the left side. So this is a positive, so we make it a minus. This is 2 log 6, and we bring this log 3 over to make it a minus. Now here we have x's, so we'll factor out the x because x is common. So x comes out to give you 2 log 3 minus log 6. You're dividing x into the two of these, and this gives us 2 log 6 minus log 3, and we divide by 2 log 3 minus 6 on each side. 2 log 3 minus log 6, they cancel, so x is equal to 2 log 6 minus log 3, 2 log 3 minus log 6. So that's an exact answer, but we can tidy that up because we can take the power and move in front. 2 to the 6, 2 to the 3, sorry, 2 raised to the 2 goes up to the 3, so that's the 3 squared. I just said it backwards. So that gives us the log of 36 minus the log of 3. That's the log of 9 minus the log of 6. And the subtraction of logs is the log of the quotient, so 36 divided by 3 is 12. And 9 divided by 6, so 9 over 6 is 3 and the 9 goes 3, 3 and the 6 goes 2, so that's 1.5. So the log of 12 over the log of 1.5, or we could have the log of 12 when the base is 1.5, either or. And again, this, if you did this on a calculator, you get approximately 6.13. This is an approximation. This is only to check to see if you're working these through okay if you wanted to check, but that's only just as a check. Changing this to a decimal and subbing it in here is checking to see if this is the exact answer, close to it. Okay, this one, a couple more to do. And now we find the exact value. I got a different equation. Again, very similar, but x is in the exponent, so we do the log of each side. So we get the log of 16 equals the log of 2x. And the log of a product is the sum of the logs. So this is the log of 16 plus the log of 6 to the x. Again, we did the log of each side, and the log of a product is the sum of the logs, and we have to move the x down. So we have x log 6, and we have x plus 6 log 2. So the power of x plus 6 goes in the front, the power of x goes in the front, and we multiply this one, so this is the log of 16. And log 2 times x is x log 2. And log 2 times 6 is 6 log 2. And again, there's x's on both sides, so we'll move them all. This one is okay. Move this one over, makes it negative x log 2. And this one is 6 log 2. And this one moves over to be log 16 minus. So we group the x's, take the x out. That gives us log 6 minus log 2. And 6 log 2 minus log 16. And we divide both sides by the log of 6 minus the log of 2. Log of 6 minus the log of 2. And they cancel, so that gives x is equal to. Now, I could write this down again, but what I'm going to do is simplify this. So this is the log of 2 to the 6 minus, because when we simplify, we got to move the number in front up to the power. If you want to write it as a single log. And so that's the 2 to the 6 is 4, 16, 64. And the log of the difference of two logs is the log of division. So 64 divided by 16 is 4. And the subtraction of two logs is the log of the quotient. So 64 divided by 16 gives me 4. The subtraction of two logs is the log of the quotient. So this is 6 divided by 2 is 3. So we have the log of 4 divided by the log of 3, or we could have the log of 4 when the base is 3. And if you check it out, if you think about it, x is approximately, think about it, what power of 3 gives you 4? So if you do your calculator on the log of 4 divided by the log of 3, you get 1.26 to the nearest 100. So that makes sense, because 3 to the 1.26, 3 to the 1 is 3, 3 squared is 9, so this power, this log, is somewhere between 1 and 2, so 1.26 is okay. And that's the exact value. So when you take this exact value, and that puts it in this equation, so to check it, take 1.26, place it here, and work out both sides, and they should be approximately the same. But we're stressing the exact value. Find the exact value. Now we have a little different one. Same thing, but we have a times. Notice this base and this base is not the same. So we can't add these exponents together. But we have to do the log of each side. So we do the log of each side. Now that we got the log done, we have, and before, notice I got the log of a product. So the log of the product is the sum of the logs. So the log of a product is the sum of the logs. So notice the product becomes the sum of the logs. Now I got each one individual logs. Now the power rule, the x minus 1 goes in front, the x plus 1 goes in front, and the x plus 2 goes in front of the log because of the power rule. We multiply all these out, so there's x log 12 minus log 12. Log 3 times x is x log 3 plus log 3. And log 2 times x is x log 2. Log 2 times 2 is 2 log 2. Notice now we have we got an x here, an x here, and an x here. So we'll group x log 12. This one is coming over to the left to become minus log 3, minus x log 3. This one is going to the left to become a minus x log 2. And this one is staying here, so this is 2 log 2. This one is moving to the right to become a plus log 12. And this one is, well, that's the log 3 is also there, so I got log 3 here. So I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's log 3. That's 2 log 2. And this becomes a plus. All these x's come out because of factoring. So I get the log of 12 minus the log of 3 minus the log of 2. And just write this down again. I could simplify it, but I won't wait for another line to do it. And so we divide both sides by the log of 12 minus the log of 3 minus the log of 2. Log of 12 minus the log of 3 minus the log of 2. That cancels. X is equal to. Now, I could write this down again, but to save time, I'm going to take this 2 and raise the only power. So I'm going to take, that's the log of 2 squared, log 12, log 3, and write down the denominator. And we have the log 2 squared is 4 plus log 12 plus log 3. This is the log of 12 minus the log of 3 minus the log of 2. And so this is, notice here, we got the sum of the logs, so that's a 4 times the 12 times the 3. And this is a subtraction, so it's a division, and that's a subtraction division, so that's the log of 12 divided by 3 times 2, because this subtraction, 2 of these are subtraction, so both 3 and 2 are dividing into 12, so that's the log of, that's the 3 times 4 is 12, 12 times 12 is 144, and that's 12 divided by 6 is the log of 2. So that's the exact answer, or we could have, that's the log of 144 base 2. And again, x is approximately, if you want to check, what power of 2 gives you 144? Well, a 6 is 64, a 7 is 128, so if you check with your calculator, 7.17 makes sense. So 2 to the 7.17 gives you 144. So this is the approximate value, but the exact answer is the log of 144 divided by the log of 2, or it could be written down the log of 144 base 2. So again, I have 3 of them here this time. A very important skill when you group these together and factor out the x, and then you divide, you get x by itself. Just extra problems to help you use your math skills. That brings us to the end, and again, if you like my video, click on the like button. If you're not a subscriber and you want to subscribe, click on the subscribe button. And visit my math website, www.mathfullyexplained.com, to find out the information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye bye.